lesson 4.4, we're proving triangle congruence using side, 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 and side angle side. So the two things that we'll be learning is to use the side, side, side postulate to test for triangle congruence and to use the side angle side postulate to test for triangle congruence. So postulates, again, are accepted without proof, and you can see why on this one because it's pretty obvious. If the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent, and that's abbreviated SSS. And so they're using the tick marks. 1, 1, so side AB is congruent to XZ. 2 ticks, so BC is congruent to YX, and 3 and 3, so AC is congruent to YZ. So if the sides are all the same, they have to be the same shape. The wings of one type of moth form two triangles. Write a two-column proof that if triangle EFG is congruent to triangle HIG, if EI is congruent to FH, FE is congruent to HI, and G is the midpoint of both segments EI and FH. Well, they gave us lots of given. So we have segment FE is congruent to HI, and G is the midpoint of EI, so that's going to make those two congruent, and G is also the midpoint of FH, so that means those are congruent. Okay, that's just marking up what I know about midpoint, but we have to actually state that. So step 1 was just stating the given. So 2, we need to say what I already marked on the diagram, that segment FG is congruent to segment HG, and segment EG is congruent to segment IG. And then finally, because all three sides are congruent, we can say the two triangles are congruent by side, side, side. Example 2, they gave us the ordered pairs for the vertices of two triangles and asked us to determine whether they are congruent. Again, we get to practice distance formula. So for WD, we're going to have square root of 3 squared plus 2 squared. That's going to be square root of 9 plus 4 would be 13. Then we could do dV. So that looks like 1 squared plus 1, 2, 3, 4 squared. So I get square root of 17. And then finally, WV looks like 1, 2, 3, 4, 5, 6. 6 squared plus 2 squared. So we get the square root of 36 plus 4. And I'm not even going to simplify the radical because I don't think it matters. And now when we come over to the other triangle and do ML, I can count 2 and 3 there also. So I still get square root of 13. For LP, I can count 4 and 1. Doesn't matter which one's first. And then finally for MP, I can count 2 and 6. So 2 squared plus 6 squared equals C squared. So we're going to take square root. And I get the square root of 40 there also. So since the sides are all congruent, we can conclude that the triangles are congruent as well, side, side, side. Okay, the order matters. So where we had WD was congruent to ML, I have WD and ML in the same order there, and DV is equal in measure to LP, so those are in the same order there as well. So make sure when you write your congruent statement, you line up the corresponding parts. And the reason these are congruent is because of the postulate side, side, side. So our other postulate that we have is the side angle side congruence postulate. If two sides in the included angle, so the angle that is included between the two sides of one triangle are congruent to the two sides and included angle of the other triangle, then the triangles are congruent, and that's abbreviated side angle side, SAS. For our third example, they asked us to write a flow proof, and they marked it on the diagram, which is nice, that QR is parallel to TS, that's what the arrow is for, and RQ is congruent to TS, that's what the little tick marks are for. And they want us to prove that triangle QRT is congruent to triangle STR. A flow proof, it's easy to see which parts the order doesn't matter in. It doesn't matter which of the given we state first, and it doesn't matter when we state that RT is congruent to itself by reflexive. Now it follows from the parallel lines that angle QRT is congruent to angle STR because alternate interior angles are congruent, so they drew an arrow showing those two connect. But these two don't connect to that at all, so they're just going to the next thing there. So the parts we need to see for the side angle side congruence, I've got a side included angle side, side included angle side. So we can say the two triangles are congruent by side angle side. And that's what a flow proof looks like. Not as structured as a two-column proof, but I kind of like it. For example 4, they ask us which postulate can be used to prove that the triangles are congruent. And if it's not possible to prove they're congruent, we're supposed to write not possible. Well, the first one is side angle side. And the second one, so this would be part B. They gave us two sides already, and then we can know that the shared side is also congruent, so that one would be side, side, side. The two big ideas for lesson 4.4 were the side, 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 and side angle side postulates. So if all corresponding sides of two angles are congruent, then the triangles are congruent. And if two corresponding sides of two triangles and the included angle are congruent, then the triangles are congruent.